Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 316, minimum number of operations to make array similar. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one is a sort of a greedy, a little bit of a tricky greedy to at least prove, but once you get the idea, I think it does come, a similar thing comes up a lot. The key thing to know, to maybe make an observation on, which may not come without a lot of practice, but I guess, I don't know if I have a lot of practice, but I've seen this in enough times, and this took me about 5 minutes, it is possible to make nums in a target, right? Meaning that there's no impossible case. I don't know that that's the only thing, but it means that there's no decision and there's no weirdness. But the idea behind this problem is, I don't know that there's a name for this type of thing, but it's just that you're forced in a way, right? Yeah. And this forcedness means that you have no decision to make here. What I mean by that, right? Meaning that, okay, well, this greedy allows you, I think I get this question a lot on because I use this same vocabulary and sometimes I'm not very clear to be, that's my fault. But it is something that I think maybe is quote unquote obvious because to me, because of years of practice, and may not be obvious to you, which is why I'm trying to be better about it. But the idea here is that, okay, let's say you have two sort of array, and let's actually change the problem a little bit so that so that it just change the problem a little bit so that instead of +2 and -2, it's +1 and -1. I'll show you in a second why it doesn't really matter. Or like it's a very similar problem with a minor adjustment. But let's say you have two lists, and you have like a target list, of course. And I didn't really fill it out quite correctly, but pretend that they added up. That is possible. I don't know if this is possible, but pretend that they are. Pretend that there are more numbers that makes it possible in the end, if you will. So here, after sorting, what happens, right? Well, after sorting, the forcedness is that, well, one has to go to 3, right? Why? Well, you can use a sort of a, I guess I did use, say, exchange argument, but it's sort of an exchange argument at the end, right? Because here, let's say, our initial pairing is something like this. Something like that, right? Dot, dot, dot again. The exchange argument is saying that, well, if we exchange the way that we make a pairing, will it be more optimal? The answer, you could show the answer very quickly, right? Which is that no, right? So in this case, okay, let's actually do the math. I didn't do the math. So let's say in this case, just look at the first two numbers, it costs 2 and 3, right? Just like, this is equal to 2, this is equal to 3. So let's say we changed it to 2. This costs us 4, this costs us 1. So this actually means that nothing has changed, right? The only thing that yeah, so that means that it almost actually doesn't matter. Well, in this case it doesn't, but let's say well, in this case it doesn't, right? But let's say we have the last number. This is only because they both go in the same direction. I think I made a mistake here. So let's say we have 6 going to 5 instead, right? This is just a random bigger number. So this is 2, this is 1. Now let's say we have 6 going to 3. Well, this is equal to 4, this is equal to 3, right? So that means that the exchange argument does not work. The exchange argument is that if you exchange it, can you get a better answer? And the answer is going to be no in both cases, right? Meaning that there are only really 2 cases. The other one is not possible. The other one, if you're thinking about, okay, so there are only 2 cases, which means that are possible, which is 1 equal to 3 and 2 is equal to 2 goes to 5, and then the other possibility is where the other one goes in the other direction, right? Obviously, the other possibility is not possible. Well, not possible in the beginning. We'll talk about the borrowing in the future. And what I mean by that is that you have like 6 to 5 and 10 to 6, I guess, right, or something like that. Well, this is not possible without borrowing numbers from the past. So we'll talk about that separately. But as you can see from the exchange argument, that it doesn't have, in this case, it gives you the same number. So so you so you might as well do it this way, because the other because doing it sorted this way gives you the probability that in this other scenario it always gives you the more optimal answer, and you don't, so you always change these things. Though I guess in theory you can, well, that's what I would say as a proof, but actually, as you will see, it actually doesn't matter, right? Only in the sense that if you group all the positive flowing ones and the negative flowing ones, you'll see that they cancel out. I'll get into that in a little bit. So, but I'm just trying to do a somewhat of a mathematical proof, but maybe still a little bit hand wavy, to be honest. But yeah, and you kind of see them all fit together by this concept of borrowing. But yeah, so maybe but another way of thinking about it though is this, like grouping them for positive flow and the negative flow, as long as and of course you have to adjust it by doing this thing, the two part later on. But let's pretend that it is plus or minus 1, and therefore all this, it doesn't, within it doesn't matter, and all the negative one going the other way as well, like 6 to the third to the 10, to 6, like all the negative floating ones also doesn't matter, because you can use the same exchange argument to show that it doesn't matter, right? The only case that matters is that you have to segregate the two, bifurcate the two. Okay, and then now, let's say now we have this mapping that allows us to kind of group them in that way, right? By nature of these things, that's how it's going to group, because they're both monotonically increasing functions, so it will never it should not, well, so yeah, so it'll group them in that properly anyway. And then the idea left is this idea of borrowing from the future, right? Let's say now you have 1 to 3, 2 to 5, or 4 to 7, ... right? Well, because it's always possible, we go, okay, the idea here is that two moves, let's borrow -2 from the future, or put up here, so yeah, right? That's -2 from the future, right? Because now we're assuming that this pair in the future will be paired with a negative flowing move, right? That's basically the idea. And in that way, it is greedy, because you can always match something. It doesn't matter where it comes from; it always matches something, right? Like almost like like if you subtract 2 moves, always will get one from the future, as no matter where you get it from, as long as it's optimal for that thing, right? It's almost like you have a lot of cups with water, and you're just pouring it into some of them, and of course you may not, or it's not in this case the moves don't have to be 1-to-1, which allows this to happen as well, right? What I mean by that is that it could, let's say, let's rewrite this a little bit. Let's say we do 1 to 20, so this requires 19 moves. Let's borrow -19 moves from the future, and then in the future it may be that you just have 20 to, I don't know, 18, 21 to 20, and this means that use -2 moves, use -1 move, right? So like we don't have to, because these 19 moves can come from anywhere, we can do it this way because it makes sense that like 20 has to go to 18 no matter what. Then it doesn't matter how it gets there, right? On the other direction. That's basically the really long, greedy pseudo proof attempt. Hope that makes sense. And the way that basically we do the plus and minus 2 is just keeping track of the parity, meaning that all the odd numbers can change into other odd numbers, and all the even numbers can change into the other even numbers. And if we do that, then that's basically it, really. And then you do and then it becomes what we just said, except for maybe some. So this is my code. As I said, we sort nums and target. We have the I actually thought I was going to keep track of the counting, but we don't even need that because the number of moves is just the number of moves in one direction, but divided by 2. So yeah, so I even put in an odds and even function so that I could sip the odds and evens, and they're in their own little world. And here because if the number is 6 moves away, or sorry, 6 numbers away, that's 3 moves. So that's basically all this is saying, is that we take the delta and then divided by 2, we add it on this side. If we add it to the other side, well, this is evens, but basically if you add all the idea here is that we add the absolute value of what we're trying to find, and then divided by 2, because we know that we're adding both the negative contribution and the positive contribution, and then we divide by 2 later on. And that's if we have one set of things, and then later we just do the other set, and that's pretty much it. I think my explanation video is way longer than my actual self, and to be honest, this is a pretty okay problem. Most of my self timing is just based on just proving to myself that it is correct. So yeah, that's all I have for this one. Let me know what you think. Oh, I didn't do the analysis. This is gonna be n log n just because of the sorting. Everything else is O of n. So yeah, that's all I have. So you could watch me solve it live during the contest now. Doing a silly thing. Okay, I don't know what to tell you. Though I did do the. It's a good practice on a ternary search. I still hate it. My first solution should have been good enough. All it does is a million operation. Come on, friends. Yeah, sure, some smaller ends. I shouldn't need to do a million. Maybe I could have special case the smaller end. I don't know. I think does n have to be one of the answers? I don't even know, to be honest. Maybe it has to be the median. I don't know. Maybe it's the median or something really crappy like that. No, that's not true. You could shift all the weight on one side. Okay, let's focus on this one. We could think about the other problem next. Okay, so nums and target of the same length. Okay, you can take I and J, and basically you're okay. So basically you're just taking 2 from one number to put the other, and you're trying to make a target. Is it always possible? Similar to target. Okay, what does similar mean? 2, 10, and 4. The frequency of each element. Okay, so it doesn't have to be the same. It just has to be in the weird order. Okay. Do we ever want to? It is possible. Okay, so it's always possible. How am I doing on time anyway? Okay, wow, people finish very quickly. I am not doing so well on whatever. People already finished Q4. But this one I blame I don't know. This one I blame myself. Okay, stop stalling. Focus. Okay. People did do it okay though. So let's see. What is n again? N is 10 to the 5th. So we need something a little bit smarter. Is it greedy? Sort and whatever. It's sorting. Yeah, I think it's just greedy though, right? I can't really figure out how maybe if I don't though. Maybe I'll just eat a wrong answer on greedy and then be a little bit better. Okay, sorting it, and then we take the smallest number, and then we take wouldn't be the next number. Well, we can always borrow. So okay, so we don't even need it to be that smart. We can borrow numbers from the future. So let's just say count is equal to 0 for I, a, b, and zip of nums target. Okay, if a is not equal to, if a is greater than b, I mean, I think we just go for the scenarios, right? If a is equal to b, we continue. If a is greater than b, then we need to give number to the future, right? Okay, so to count, then you have like, account or something, like some account number. So then we add it to be do we even, oh yeah, we well, I don't even need, if it is greedy, why don't we just do something like a minus b right? And then just count over 2. How is this not right? 2 1 0. No, where's the 1 go? One and 2, 3 and 5, right? So the 2. Oh, I'm doing this in a funky way, but I think the idea is still the same. Is that to get the 2, we don't get the 2 to the 3. So that part is a little bit weird. I messed up here. And also we can just partition it to odd and even. So I think this is mostly right, but let's do something like oops. Whatever. Too late. What are you doing, Abby? Okay, and then just that's a good example case, actually. I probably would have just YOLO submit. Okay, let's go submit. Maybe I'm wrong. But, yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, anything in between. I'll see you later. Stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.